Hi, welcome back. And today we are going to discuss about types of grounding. So, what is grounding? So, a physical connection between electrical circuit and earth is called grounding. So, here it provides very low resistive path. So, it offer if any fault current or any leakage current is appeared in the electrical circuit, immediately the fault current or leakage current that should be taken into the earth. So here we have to maintain zero potential difference. So while doing the empathy with the different users like electrical engineer, facility manager, end users, regulatory bodies, etc. So from their perspective, so the need and what is the reliability and what is the compliant grounding and what is why it require low maintenance system so far the ensuring the continuous equipment operation and expect invisible safety protection and why it is mandatory for public safety, etc. So in the main problem of the earthing system, how might we design grounding system effectively, which is allow and faulty current or leakage current, which will immediately transfer from the circuit into soil, that is earth. So here it may vary the soil property. If soil properties get changes, the resistance of soil is also gets changes. So it's globally varies so that according to the geographical locations and the different equipment grounding, it may be and sensitive or it may be an heavy etc. So here we have to balance the cost with respect to the safety requirement for the domestic as well as industrial applications. So the main objective of the earthing here we have to offer less than 5 ohm for residential and less than 1 ohm for substations. So in the types of grounding system, already we have discussed about the plate earthing, pipe earthing, rod earthing, strip earthing, and mesh earthing a little bit. So here we will see in detail the plate earthing system. So here we can use either copper or galvanized iron plate. It is in the dimension of 600 mm into 600 mm, that is length, into 3 mm thickness. So here it will be buried with through 3 meters below the ground level. So here we have to bury with the depth of 3 meter, and we have to keep the galvanized iron plate in the ground. So it should be surrounded by different layers like salt, charcoal, and some of the rocky rocks. So and also we have to maintain the moisture for better conductivity. So that is the around the earthing system we are always maintaining the wet conditions because the wet condition it provide very low resistance when compared to the dry conditions. So it is mainly suitable for residential building, small commercial building, and areas with the space constraints. Okay, so that we can use this plate earthing. So mainly it is made up of galvanized iron because copper is very cost and galvanized iron is intermediate only, somewhat moderate. And in the pipe earthing system, so the specifications of the galvanized iron pipe, it will be in the dia of 38 mm. But you can see in the plate type, it will be 3 mm. But here 38 mm diameter and it will be buried in the depth of 2.5 mm length. So also here we have to for moisture absorption property should be included. The installation, the vertical interaction with funnel top for salt, charcoal, and mixture, it should be surrounded by the pipe earthing system. We should not just fill it by using the not only by using the soil, also we have to use some of the salt as well as charcoal and some of the big size rocks, medium size rocks can be used. So what is the advantages of a pipe earthing system? It will be deeper earth contact and it provide very lower resistance and it is suitable for high sensitivity of soils. Rod, strip and mesh earthing. So this will be a rod earthing. So here we are using the copper rods. So in the rod earthing, copper rods are in minimum of 12 to 25 diameter and it will be driven the 5 meter deep. It will be ideal for a rocky terrain. For strip earthing, here also we are using the copper strips for 25 wide in horizontal. It can be used for long perimeter protections. And for mesh earthing, it is integrated conductor grid. It is essential for substations and high voltage installations of power generation stations, substations, or intermediate stations, etc. So the while doing the prototype and testing, so first step we have to do an site assessment. So here we have to measure the soil resistance using the beggar. And the second step, system design. So select we are what is the different types of grounding, whether it's a plate or rod or strip. So we have to design a system for based on the soil conditions and the load requirements. And the third step, we have to follow the international standard IS 3043 for the implementation of earthing system. And fourth, we have to test. And already we are done a site assessment. Again, and finally, we have to do an testing whether the earth resistance is less than 5 ohm or not. If it is residential. And if you go for substations or a generating station, it should be less than 1 ohm. So at the final stage, we have to do this testing and frequently we have to monitor the inspection. Every 6 months we have to do an assessment and we have to ensure the wet conditions surrounding the earthing area. And these are the few applications like in the power distribution area, industrial plant, lighting production system, and IT infrastructure, etc. So here in the types of grounding, we are discussed about the plate earthing system. You can use copper or GI plate. So in the dimension of 600 into 600 so here we have to use salt and charcoal around the plate earthing. And for pipe earthing, here also we can use copper or GI pipe, and it should be vertical and moisture protection. It should be ensured. And for strip and mesh, horizontal conductor, grid for substations. And for rod earthing, copper rods can be used a very deep insertion and it is preferably for rock terrain. So this is a summary of types of grounding and the security challenge. So why does adding salt and charcoal around earthing electrode it improve performance? So and the second one, can you achieve zero earth resistance in practice? So if you know the answer, you can put in the comment sections. And these are the assessment. So you can compare plate earthing and a pipe earthing system, so which is preferable for manufacturing industry, especially rocky terrain. So you can put your suggestion in the comment section. And these are the few references and references and websites for this particular topic. Thank you.